In this video, I will walk you through free response question number 5 from the 2018 AP Calculus exam. Part A, find the average rate of change of function f on the interval from 0 to pi. Average rate of change is just an old school slope, basically y minus y over x minus x. If you evaluate the function at pi, you get e to the pi cosine pi. Next, you subtract the evaluation of the function at 0, so minus e to the 0 cosine 0, all over pi minus 0. Cosine of pi, which is right here, will be -1 because cosine is the x value. So this is -1 times e to the pi, so I'm just going to write negative e to the pi. E to the 0 power, like any constant to the 0 power, is 1. But cosine of 0, which would be right here, is 1 because that is the x value. So this is basically 1 times 1. So I'm just going to put 1. Pi minus 0 is pi. So that's it. This is the expression for the average rate of change on the interval from 0 to pi. Part B, what is the slope of the line tangent to the graph of f at x equals 3 pi over 2? The slope of a tangent line at a point is a long way of saying the derivative. So they are really asking us to find the derivative at 3 pi over 2. So let's find the derivative and evaluate at 3 pi over 2. Clearly, we will need to do the product rule. We have this yellow factor times this blue factor. So according to the product rule, the first time through, I take the derivative of the yellow factor. The derivative of e to the x is e to the x. So it looks the same, but that's the derivative. I leave the blue factor alone this time around. And then I put a plus. Then I go back through the yellow and blue again. The second time around, I leave the yellow factor alone. So leave in the yellow alone. And then I take the derivative of the blue factor. The derivative of cosine is negative sine. However, I prefer to put this negative sign here in the middle. So this is the derivative. I'm noticing that we have a common factor of e to the x. So just for fun, I am going to factor that outside of the parentheses. So I will have e to the x times cosine x minus sine x. So the derivative will give you the slope of the function at any point, including this one. So let's evaluate the derivative at 3 pi over 2. So we will get e to the 3 pi over 2 power times the cosine of 3 pi over 2 minus the sine of 3 pi over 2. What is the cosine of 3 pi over 2? Well, 3 pi over 2 falls right here. Cosine is the x value, so this is 0. What about sine of 3 pi over 2? Sine is the y value, so this is -1. So notice that we have minus -1. Obviously, that will be plus 1. So f prime at 3 pi over 2 is equal to e to the 3 pi over 2 power times 1, which is simply e to the 3 pi over 2 power. Time for the summary statement. The slope of the tangent line to the graph of f of x is e to the 3 pi over 2 power at x equals 3 pi over 2. Part C, find the absolute minimum value of function f on the interval from 0 to 2 pi. Justify your answer. In order to find the absolute minimum, we use something called a candidates test. That's where we generate a list of possible candidates for the location of the absolute minimum, and we test each one to see where the value of the function is the least. We already have two candidates right here because it's always possible that the absolute minimum will occur at one of the endpoints of the interval that we are given. The other candidates will be the critical values, which either cause the derivative to equal 0 or to be undefined. Here is the derivative that we found back in step B. I'm going to copy this down now. E to the x, as well as cosine x and sine x, are all defined everywhere. So we don't need to worry about where f prime is undefined. Instead, we will just set the derivative equal to 0 and solve to find the remaining candidates. By the zero product property, I can set e to the x power equal to 0, or cosine x minus sine x will equal 0. If you think about this first equation for 2 seconds, you will realize that it has no solution. E is a constant, approximately 2.72. There is no power that you can raise e to that will cause the expression to equal 0. Even if I try to do e to the 0 power, that's 1, not 0. So this has no solution. So our only hope is going to come from the cosine x minus sine x equals 0. Adding sine x to both sides, we have cosine x is equal to sine x. So think about the unit circle. Remember that cosine and sine are the x value and the y value on the unit circle. So if I want to know where cosine is equal to sine, look at the unit circle and think, where on this unit circle will the x value and the y value be the same? Well, at pi over 4, the cosine is radical 2 over 2, and the sine is also radical 2 over 2. Then at 5 pi over 4, cosine is negative radical 2 over 2, while sine is also negative radical 2 over 2. These are the two places on the unit circle, between 0 and 2 pi anyway, where the x value and the y value are equal. So cosine x equals sine x at x equals pi over 4 and 5 pi over 4. So we have these two candidates. These are possible locations for the absolute min, as well as 0 and 2 pi. So it's time to make our candidates test. Go ahead and make an old school T-chart like this. Be sure to actually label it as candidates test. So our x values will be the candidates that we have identified. We have the 0 from the beginning of the interval, and then we have pi over 4 and 5 pi over 4, which we found, and then the end of the interval, which is 2 pi. So we have these 4 candidates. So now we simply evaluate the original function at each one of these candidates and see which one gives us the minimum value. So here's the original function. Let's evaluate at 0. That will be e to the 0 power times cosine of 0. E to the 0 power is 1, and cosine of 0 is also 1. So this has a value of 1. How about pi over 4? So that will be e to the pi over 4 power times the cosine of pi over 4. So I have e to the pi over 4 power. The cosine of pi over 4, some people like to say radical 2 over 2, as I mentioned earlier in this video. But my favorite is to actually say 1 over radical 2, which means the same thing. I guess I like this a little bit better because I can do things like this with it. I have e to the pi over 4 power divided by radical 2, which just is a little bit more meaningful to me. Similarly, if we evaluate the original function at 5 pi over 4, we have e to the 5 pi over 4 power times the cosine of 5 pi over 4. The cosine of 5 pi over 4 is negative 1 over radical 2, so I have this, and I can stack that up into a nice fraction like this. Notice that this one is negative, though. So the previous two values were both positive. They were greater than 0. So this is less than 0. So I'm looking for the minimum. So this is definitely winning so far. If we evaluate at 2 pi, then we have e to the 2 pi times the cosine of 2 pi. The cosine of 2 pi is 1. So this is just going to leave me with e to the 2 pi power. And we have a winner. Because this is the only negative value that was generated by our 4 candidates, negative e to the 5 pi over 4 power divided by radical 2 is the absolute minimum. And notice that it occurs at an x value of 5 pi over 4. Let's write this up as a summary statement. F of x has an absolute minimum of negative e to the 5 pi over 4 divided by radical 2 on the interval from 0 to 2 pi. Part D. Let g be a differentiable function such that g at pi over 2 is equal to 0. The graph of g prime, the derivative of g, is shown here. Find the value of the limit as x approaches pi over 2 of f of x divided by g of x, or state that it does not exist. Justify your answer. Here is a key detail that students often overlook, but if you do not include this statement in your solution, you will not get full credit on the AP exam. They told us that g is a differentiable function, and the fact that g is differentiable implies that g is continuous. But why do we need to write this down? Well, at some point as we evaluate a limit, we usually use direct substitution. But direct substitution only yields the limit for a continuous function. So we have to state ahead of time that g is continuous so that we are allowed to use direct substitution. In fact, let's do some direct substitution right now. We have f of x divided by g of x, but f of x is e to the x power times cosine x. So we have this. As we do our direct substitution, let's keep the numerator and denominator separate by using these arrows. That will avoid saying that the limit is equal to an undefined expression, which would lose us points on the AP exam. So doing direct substitution in the numerator, we get e to the pi over 2 power times the cosine of pi over 2. The cosine of pi over 2 is 0. It's the x value at the top of the unit circle. And then 0 times e to the pi over 2 power is 0. So this is equal to 0. In the denominator, we just have g of x. So if we do direct substitution, we get g at pi over 2. But we are told in the setup that g at pi over 2 is also equal to 0. The reason why we wrote this all out is because if the numerator and denominator are both approaching 0, we are allowed to use L'Hopital's rule. L'Hopital's rule says we can take the derivative of the numerator and the derivative of the denominator without changing the limit, as long as the original limit was approaching 0 over 0 or infinity over infinity. So let's go ahead and take the derivative of the numerator. We're going to have to use the product rule. We have e to the x times cosine x. So according to the product rule, I will take the derivative of the yellow function and leave the blue function alone. The derivative of e to the x is e to the x, that's my favorite. And I leave the cosine x just sitting there. And then I put a plus and I go through it again. The second time through, I leave the yellow function alone, so there's my e to the x left alone, and I take the derivative of the blue function. The derivative of cosine is negative sine. So I'm going to put my sine x here, but I'm going to put the negative right here. The derivative of the denominator is simply g prime of x. Let's try to evaluate this limit by direct substitution. So now we have this. Let's evaluate this term by term. We have e to the pi over 2 power, but cosine pi over 2. Pi over 2 is up here. Cosine is the x value, so that is 0. Minus e to the pi over 2 times sine of pi over 2. Sine is the y value, so that is 1. But what about g prime at pi over 2? What do I do with that? Luckily, they gave us this handy-dandy graph of g prime. We can use it to evaluate g prime at pi over 2. So here's pi over 2 right here, and here is the value of g prime at pi over 2, which is 2. This term is being multiplied by 0, so it is gone. That leaves me with negative e to the pi over 2 power in the numerator and 2 in the denominator. So that's it. This is the limit. I just want to emphasize one more time before I end this video. This little part that I did here in blue is not optional. You have to show that the numerator and denominator are both approaching 0 in order to use L'Hopital's rule. It also works if the numerator and denominator are both approaching infinity.